So from uracil monophosphate we can synthesize thiamine monophosphate. The only difference between this uracil nucleotide base and thiamine nucleotide base is presence of CH3, presence of methyl group. If we add this methyl group on uracil, it will become what? It will become thiamine. So it means that we can add this methyl group on uracil to convert it into thiamine. Well, there is a flying animal. This flying animal, in its mouth it will bring this methylene group, and it will donate its methylene group as well as two of its wings. It has 4 wings, 4 hydrogen wings. So it will donate 2 of its wings, it will lose 2 of its wings as well as a methyl group in the presence of thymidylate synthase enzyme, and it will convert uracil into thiamine. It will convert uracil monophosphate into thiamine monophosphate, and of course it has now lost 2 of its wings. Now to get 2 of its wings back, it has to go to a special wingifying machinery, as I call it. It will go to a special wing attaching machinery which will attach 2 wings to this flying animal, and now this flying animal is now active with its 4 wings. It is now active with its 4 hydrogen wing. It is now active, and now this active flying animal with 4 wings, it will fly towards either serine, methionine or choline and fetch the methylene group, and now it can again donate this methylene group and 2 of its wings to another uracil monophosphate molecule in order to convert it into thiamine monophosphate. So what is this flying animal? Do you know this? I know you must have heard of its name. So what is this flying animal? What? Yeah, it is, yes, it is folic acid. Folic acid, flying animal, folic acid. So the folic acid or flying animal with 2 wings, it is dihydrofolate. It is dihydrofolate. It is its inactive form. To get activated, it has to be reduced. 2 more hydrogen atoms has to be added to it. So this enzyme, this wing attaching machinery is dihydrofolate reductase, which will attach 2 more wings to it, and now it will become tetrahydrofolate, and this tetrahydrofolate will go to either serine, methionine or choline to fetch a methylene group, and this methylene group will be attached to its nitrogen 5 and 10 at nitrogen 5 and 10 position, and now it will become N5 and 10 methylene tetrahydrofolate. It's very easy to understand, I think. So this N5 and 10 methylene tetrahydrofolate, it will again donate these methylene group to dihydrofolate reductase, and it will become it will donate its methylene group to uracil, and it will convert into thiamine, and it will lose its wings. So this cycle can continue. Now here is so you got the point. Are you really understanding it? Okay, good. So there is a T-Rex dinosaur. This T-Rex dinosaur, it resembles with this flying animal, and because of its structural resemblance, it gets stuck into this wingifying machinery of this dihydrofolate, and it will block this dihydrofolate reductase, and now this dihydrofolate, it is now crying because it cannot get the wings. It cannot get its wings, so it won't be activated, and if it won't be activated, it won't be able to fetch this methylene group from these. So now it won't be working properly. So this, what is this T-Rex dinosaur which is blocking dihydrofolate reductase? Do you know the name of this T-Rex dinosaur? T-Rex. Yes, it's Methotrexate, Methotrexate. Methotrexate and some similar drugs, Pretrexate and some other drugs which are of this category. We will discuss that later. So methotrexate is dihydrofolate reductase. It blocks this process, and sufficient thiamine won't be formed, and if sufficient thiamine won't be formed, DNA will have thiamine, DNA would be thiamine less, and DNA synthesis will be arrested. So are you really clear about this?